Hi everyone, I'm Whit Roy. Today we are going through every formula in the EWRB exam formula sheet. The purpose of this lesson is simple. You listen, you repeat, you understand what each symbol means and what the units are. We are not solving problems. We are not doing calculations. We are only learning the formula meanings. Let's begin. Now we are starting Group A, which is all about basic electrical formulas and reactance formulas. These formulas are used for AC circuits. They help us understand voltage, current, resistance, impedance, inductive reactance, and capacitive reactance. In this group, we learn how impedance is made from resistance and reactance and how frequency affects reactance. Now let's go through each formula one by one. Now we go to the first formula. The formula is V equals I times Z. This formula is used to calculate the voltage using the current and the impedance in an AC circuit. V means voltage and the unit is volts. I means current and the unit is amperes. Z means impedance and the unit is ohms. Repeat, V equals I times Z. Now we go to the second formula. The formula is I equals V divided by Z. This formula calculates the current when we know the voltage and the impedance. I means current and the unit is amperes. V means voltage and the unit is volts. Z means impedance and the unit is ohms. Repeat, I equals V divided by Z. Now we go to the next formula. The formula is XC equals 1 divided by 2 pi FC. This formula is used to calculate capacitive reactance in an AC circuit. XC means capacitive reactance in ohms. F means frequency in hertz. C means capacitance in farads. Repeat, XC equals 1 over 2 pi FC. Now we go to the next formula. The formula is XL equals 2 pi FL. This formula is used to calculate inductive reactance in an AC circuit. XL means inductive reactance in ohms. F means frequency in hertz. L means inductance in henries. Repeat, XL equals 2 pi FL. Now we go to the next formula in Group A. The formula is Z squared equals R squared plus bracket XL minus XC bracket squared. This formula is used to calculate the total impedance of an AC circuit. Z means impedance in ohms. R means resistance in ohms. XL and XC are reactance values, also in ohms. Repeat, Z squared equals R squared plus bracket XL minus XC bracket squared. Now we go to the last formula in Group A. The formula is Z equals R plus or minus JX. This formula shows impedance as a complex value with a real part and an imaginary part. R means resistance in ohms. JX represents the imaginary reactance component. Repeat, Z equals R plus or minus JX. Now we are starting Group B, which is all about power in AC circuits. In this group, we learn the formulas for real power, reactive power, apparent power, and power factor. These formulas help us understand how electrical energy is used, how much power is wasted, and how power behaves in three-phase circuits. We will also look at the relationship between voltage, current, and phase angle. Let's go through each formula one by one. Now we go to the first formula in Group B. The formula is P equals V times I times cos theta. This formula is used to calculate real power in an AC circuit. P means real power in watts. V means voltage in volts. I means current in amperes. Cos theta means power factor. Repeat, P equals V times cos theta. Now we go to the next formula. The formula is P equals I squared R. This formula is used to calculate power loss in a resistor, also known as heating loss. P means power in watts. I means current in amps. R means resistance in ohms. Repeat, P equals I squared R. Now we go to the next formula. The formula is P delta equals 3 times P star. This formula is used to convert star power to delta power in three-phase circuits. Repeat, P delta equals 3P star. Now we go to the next formula. The formula is power factor equals P divided by S. This tells us how efficiently electrical power is being used. P means real power in watts. S means apparent power in voltamps. Repeat, power factor equals P over S. Now we go to the next formula. The formula is P equals root 3 VLIL cos theta. This formula is used to calculate real power in a three-phase system using line voltage and line current. P is real power in watts. VL is line voltage in volts. IL is line current in amps. Cos theta is power factor. Repeat, P equals root 3 VLIL cos theta. Now we go to the next formula. The formula is P equals 3 VPH IPH cos theta. This formula calculates real power in a three-phase system using phase voltage and phase current. P is power in watts. VPH is phase voltage in volts. IPH is phase current in amps. Cos theta is the power factor. Repeat, P equals 3 VPH IPH cos theta. Now we go to the next formula. The formula is Q equals V squared divided by XC. This formula is used to calculate reactive power in a capacitive circuit. Q means reactive power in VARs. V means voltage in volts. XC means capacitive reactance in ohms. Repeat, Q equals V squared over XC. Now we go to the next formula. The formula is Q equals V I sin theta. This formula gives the reactive power in an AC circuit. Q means reactive power in VARs. V means voltage in volts. That means current in amps. Sin theta tells us the reactive component. Repeat, Q equals Vi I sin theta. Now we go to the next formula. The formula is QC equals P times bracket tan phi 1 minus tan phi 2 bracket. This formula is used when improving power factor using capacitors. QC means reactive power change provided by a capacitor. P means real power in watts. Phi 1 and phi 2 are the before and after phase angles. Repeat, QC equals P times bracket tan phi 1 minus tan phi 2 bracket. Now we go to the next formula. The formula is S equals square root of P squared plus Q squared. This formula calculates apparent power. S means apparent power in voltamps. P is real power in watts. Q is reactive power in VARs. Repeat, S equals root of P squared plus Q squared. Now we go to the next formula. The formula is S equals root 3 VLIL. This formula is used to calculate three-phase apparent power. S is in volt amps. VL is line voltage in volts. IL is line current in amps. Repeat, S equals root 3 VLIL. Now we go to the last formula in Group B. The formula is S equals V times I. This formula calculates single-phase apparent power. S means apparent power in voltamps. V is voltage in volts. I is current in amps. Repeat, S equals V times I. Now we are starting Group C, which is about star and delta connections in three-phase systems. These formulas help us understand the relationship between line values and phase values. In star or Y connections, the phase values are smaller, and in delta connections, the phase values behave differently. These relationships are very important for motors, transformers, and three-phase loads. Now let's go through each formula one by one. Now we go to the first formula in Group C. The formula is IL equals IPH in a star connection. This formula tells us that in star, the line current is the same as the phase current. IL means line current in amperes. IPH means phase current, also in amperes. Repeat, in star, IL equals IPH. Now we go to the next formula. The formula is VPH equals VL divided by root 3 in a star connection. This formula tells us that phase voltage is lower than line voltage in star. VPH means phase voltage in volts. VL means line voltage, also in volts. Repeat, in star, VPH equals VL over root 3. Now we go to the next formula. The formula is VL equals VPH in a delta connection. This formula tells us that in delta, the line voltage is the same as the phase voltage. VL means line voltage in volts. VPH means phase voltage in volts. Repeat, in delta, VL equals VPH. Now we go to the last formula in Group C. The formula is IPH equals IL divided by root 3 in a delta connection. This formula tells us that in delta, the phase current is smaller than the line current. IPH means phase current in amperes. IL means line current in amperes. Repeat, in delta, IPH equals IL over root 3. Now we are starting Group D, which is all about transformers. These formulas help us understand the relationship between turns, voltage, current, efficiency, and voltage regulation. Transformers do not change frequency, they only change voltage and current through the turns ratio. Now let's go through each formula in this group. Now we go to the first formula in Group D. The formula is N1 over N2 equals V1 over V2 equals I2 over I1. This formula is used to calculate how voltage and current change with the number of turns on the transformer. Now let's explain each symbol. N1 means the number of turns on the primary winding. N2 means the number of turns on the secondary winding. V1 means the primary voltage in volts. V2 means the secondary voltage in volts. I1 means the primary current in amperes. I2 means the secondary current in amperes. Repeat, N1 over N2 equals V1 over V2 equals I2 over I1. Now we go to the next formula. The formula is efficiency equals power out divided by power in times 100%. This formula tells us how well the transformer transfers power from primary to secondary. P out means output power in watts. P in means input power in watts. Repeat, efficiency equals P out over P in times 100%. Now we go to the next transformer formula. The formula is percentage efficiency equals Ns cos phi divided by Ns cos phi plus N squared PQ plus P phi times 100%. This formula includes copper loss and iron loss in the transformer. N means the percentage of load. For example, 0.5 means 50% load, 1.0 means full load. S means the apparent power of the transformer, the rated kVA of the transformer. PQ means copper loss. P phi means iron loss. Repeat slowly. Ns cos phi over Ns cos phi plus N squared PQ plus P phi times 100%. Now we go to the next transformer formula in Group D. The formula is voltage regulation equals VNL minus VFL divided by VFL times 100%. This formula tells us how much the voltage drops when the transformer goes from no load to full load. VNL means no load voltage in volts. VFL means full load voltage in volts. Repeat. Regulation equals VNL minus VFL over VFL times 100%. Now we go to the last formula in Group D, the transformer impedance percentage formula. The formula is %Z equals S rating divided by S fault times 100. This formula tells us the percentage impedance of the transformer. It compares the rated apparent power of the transformer to the fault apparent power. Now let's explain each symbol and the units. S rating means the rated apparent power of the transformer in voltamps or kVA. S fault means the apparent power during a fault condition, also in voltamps or kVA. Repeat. %Z equals S rating over S fault times 100. Now we are starting Group E, which is about motors. These formulas help us understand mechanical power, synchronous speed, slip, and angular speed. They are important for understanding how motors perform and how speed changes under load. Now let's go through each motor formula one by one. Now we go to the first formula in Group E. The formula is Px equals 2pnt divided by 60. This formula calculates the mechanical output power of the motor. N means speed in revolutions per minute. T means torque in Newton meters. Repeat, Px equals 2pnt over 60. Now we go to the next formula. The formula is Ns equals 60F divided by P. This formula calculates synchronous speed, the speed of the rotating magnetic field. F means frequency in hertz. P means number of poles. Repeat, Ns equals 60F over P. Now we go to the next motor formula. The formula is slip equals Ns minus Nr divided by Ns times 100%. This formula tells us how much slower the rotor is compared to synchronous speed. Ns is synchronous speed. Nr is rotor speed. Repeat. Slip equals Ns minus Nr over Ns times 100%. Now we go to the last motor formula in Group E. The formula is omega equals 2 pi n divided by 60. This formula calculates angular speed. Omega is in radians per second. N is speed in RPM. Repeat, omega equals 2 pi n over 60. Now we are starting Group F, which includes resistance and insulation resistance. These formulas explain how resistance depends on material, length, and cross-sectional area, and how insulation resistance changes with conductor length. Let's go through each formula. Now we go to the first formula in Group F. The formula is R equals ROL divided by A. This formula calculates the resistance of a conductor. Rho means resistivity in ohm meters. L means length of the conductor in meters. A means cross-sectional area in square meters. Repeat, R equals rho L over A. Now we go to the last formula in Group F. The formula is R2 equals L1R1 divided by L2. This formula is used to scale insulation resistance with conductor length. R1 is original insulation resistance. R2 is the new insulation resistance. L1 and L2 are conductor lengths. Repeat, R2 equals L1 R1 over L2. Now we are starting Group G, which is all about capacitors. These formulas help us calculate total capacitance in series and parallel, and the charge stored on a capacitor. Let's go through the formulas. Now we go to the first capacitor formula. The formula is 1 over Ct equals 1 over C1 plus 1 over C2. This formula calculates total capacitance for capacitors connected in series. Now let's explain the symbols and units. Ct means total capacitance in farads. C1 means the capacitance of the first capacitor in farads. C2 means the capacitance of the second capacitor in farads. Repeat, 1 over Ct equals 1 over C1 plus 1 over C2. Now we go to the next formula. The formula is Ct equals C1 plus C2. This formula calculates total capacitance in a parallel connection. Now let's explain the symbols and units. Ct means total capacitance in farads. C1 means the capacitance of the first capacitor in farads. C2 means the capacitance of the second capacitor in farads. Repeat, Ct equals C1 plus C2. Now we go to the last capacitor formula. The formula is Q equals CV. This formula calculates the electric charge stored in a capacitor. Q is charge in coulombs. C is capacitance in farads. V is voltage in volts. Repeat, Q equals CV. Now we are starting Group H, which is basic trigonometry. These formulas describe the three main trigonometric ratios for a right triangle. They help us understand phase angles and relationships in AC circuits. Let's go through them. Now we go to the first trig formula. The formula is tan phi equals opposite divided by adjacent. Repeat, tan phi equals opposite over adjacent. The next formula is sin phi equals opposite divided by hypotenuse. Repeat, sin phi equals opposite over hypotenuse. The last trig formula is cos phi equals adjacent divided by hypotenuse. Repeat, cos phi equals adjacent over hypotenuse. Now we are starting Group I, which is about neutral current in an unbalanced three-phase system. This formula helps us calculate how much current flows in the neutral when the three-phase loads are not equal. Now we go to the only formula in Group I. The formula is I neutral equals root bracket IA squared plus IB squared plus IC squared minus IAIB minus IBIC minus IAIC bracket. This formula calculates neutral current in an unbalanced three-phase system. IA, IB and IC are the phase currents in amperes. Repeat, I neutral equals root bracket IA squared plus IB squared plus IC squared minus IAIB minus IBIC minus IAIC bracket. Now we are starting Group J, the last group. These are the standard Ohm's law formulas for power, voltage and current. They are the foundation of electrical calculations. Let's go through each one. Power equals voltage times current. Repeat, P equals VI. Power equals current squared times resistance. Repeat, P equals I squared R. Power equals voltage squared divided by resistance. Repeat, P equals V squared over R. Voltage equals current times resistance. Repeat, V equals IR. Voltage equals power divided by current. Repeat, V equals P over I. Voltage equals square root of P times R. Repeat, V equals root PR. Current equals voltage divided by resistance. Repeat, I equals V over R. Current equals power divided by voltage. Repeat, I equals P over V. Current equals square root of P divided by R. Repeat, I equals root P over R. Thank you for learning with me. Keep practicing the formulas and you'll master them with confidence.